Hello everyone, today we will learn and study about motion in 2D. Motion in 2D or two-dimensional motion refers to movement that occurs in a plane, meaning it involves two spatial dimensions. This can be represented by coordinates on a plane, such as the x-axis horizontal and y-axis vertical. Before we go further, let's see the learning content for this chapter. In this topic we have projectile motion in 2D and relative velocity. Let us go to introduction of projectile motion. Projectile motion is a type of two-dimensional motion where an object is projected into the air and moves under the influence of gravity and its initial velocity. It follows a curved path known as a parabola. The motion can be analyzed by breaking it down into horizontal and vertical components. Other than that is kicking the ball by the player. If a ball is kicked with an initial speed of 20 ms at an angle of 30 degrees above the horizontal, you can find the horizontal and vertical components of the velocity, the time of flight, the range and the maximum height. Understanding projectile motion helps in predicting the path of objects under gravity and designing systems that involve such trajectories. If an object is launched at an initial angle of certain angle with the horizontal, the analysis is similar, except that the initial velocity has a vertical component. Here's a detailed breakdown of how projectile motion works. Projectile motion occurs in two dimensions, which is horizontal motion and vertical motion. The horizontal velocity remains constant if we ignore air resistance, while the vertical motion is influenced by gravity, which causes a change in the vertical velocity. The equation of projectile motion are divided into two on the x component and y component of velocity. For x component stated for ux equal to u cos theta, while y component stated for uy equal to u sin theta. Beside that, kinematic equation of projectile motion can be used in this chapter to calculate the horizontal component and vertical components. Here is the example on how to calculate the maximum height, sy max. You have to take note that when calculating the maximum height, the speed on vertical or Vy must be 0 meter per second. By using the formula of kinematic equation, v square equal to u square minus 2g time to displacement, hence you will get the answer for maximum height. To calculate the time taken that reach the maximum height, you can use the formula of v equal to u plus a t, whereby the a should be considered as gravity, hence, you have to change positive a to negative g. From that, continue to substitute the value and you will get the answer for time taken that reached the maximum height. Noted that at maximum height, Vy must be 0. To find the time of flight, you have time to 2 for t. Next, to calculate the maximum range Sx max, Sxx equal u cos theta. Take a lot at example 1. Figure shows a ball thrown by Superman with an initial speed u 200 meter per second and makes an angle theta equal to 60 degree to the horizontal. Determine the position of the ball and the magnitude and direction of its velocity when t 2.0 ses. To answer the question, you have to identify the horizontal and vertical component. For answer a question, we have to take formula of s equal to u time t, hence, for horizontal component we will get the answer of 200 m from point O. Next, calculate the vertical component using another kinematic equation that's suitable and you will get the position for vertical component at 326 m. For magnitude and direction of ball velocity, you can use the formula of v is equal to u on the horizontal and vertical component. Then, insert of the info that you get from the question and find the magnitude and direction for it. For maximum height, we know that Vy is equal to 0. Hence, the time taken that reach the maximum height must be t equal to 17.6 seconds. After that, apply the answer into formula S equal to ut minus half gt to get the max height. The answer will be 1,525 meter. For C noted that they want us to find the horizontal range. Before that, we have to calculate the time flight, which is equivalent to 2 times t. Hence, from previous calculation, we have to time into 2 and you will get the answer of 35.2 seconds. Hence, you can find the horizontal range, r. From that, find the magnitude and direction using formula tangent and magnitude. The position of the ball when t is equal to 45 seconds can be calculated by using s equal to u times t. Hence, from point O you will have 4,500 m as the answer. Continue to find the position at vertical component and calculate the magnitude and direction of ball's velocity at horizontal and vertical component. The concept will be the same as previous calculation. Search magnitude and direction for both too. For next example 2, a place kicker kicks a football with a velocity of 20 ms with an angle of 53 degrees. Hence, how long the ball in the air, how far does it land and how high does it travel? First and foremost, you have to draw the path of the ball to have some idea on it. For A, you will get time is equal to 3.26 seconds as the ball are floating in the air. The ball will land at 39.24 meter at horizontal axis and the high will be 13.01 meter at vertical axis. Here is the illustration of horizontal projectile motion which go half of projectile. The slide shows how the horizontal projectile works on. Note that Uy is equal to 0 and the displacement always negative in value. Next, we will go to relative velocity. What is relative velocity in 2D? Relative velocity is the velocity of an object as observed from a particular reference frame, taking into account the motion of the observer and the object itself. Essentially, it's the velocity of one object as seen from another moving object, or from a stationary point. To calculate relative velocity, you typically use this formula VB equal to VB minus VA. Here, VWS is the velocity of the water in the shore frame, VBS is the velocity of the boat in the shore frame, and VBW is the velocity of the boat in the water frame. The relationship between the three velocities is actually the displacement of it. Let's answer some question. A boat is moving across a river with a speed of 5 ms1. The river current flowing to the right at 2 ms1. What is the velocity of the boat with respect to the ground? Firstly, let's draw the starting point of boat moving with the vector of it. Then, identify the speed of each vector and calculate their magnitude and direction. Easy peasy. In summary, projectile motion provides a comprehensive framework for understanding how objects move under the influence of gravity alone. With predictable and consistent behavior that can be analyzed and calculated using the principles of kinematics and relative velocity is crucial in various contexts, such as in collision problems, navigation, and when analyzing the motion of objects in different frames of reference. That's all for this chapter. I hope you will get more exercise. Best of luck.